Hello students, Callie Daniels here. In this video we will review the real number system, beginning with adding and subtracting real numbers. In example 1 we want to find each sum. Part A, we're going to add two negative numbers, -9 plus -2. As you think about movements on the number line, -9 is to the left of 0, and then 2 more units from there to the left lands at -11. When adding two like-signed numbers, we combine their absolute value, 9 plus 2 is 11, and then give the result the common sign, in this case a negative sign. Part B, here we're combining two differently signed numbers. So as you think about that movement on the number line, +3, and then from there, -7. Okay, it's going to land at -4. When we add differently signed numbers, just think of subtracting their absolute values. 7 minus 3 is 4, and then we give the result the sign of the term with the largest absolute value because it carries the weight. In this case, it carries the weight of that addition back to the negative side of the number line, -4. Part C is similar to Part A. We're going to add two like-signed numbers, so we know that our answer is going to be negative in the end. Okay, these are both negative. Now, let's write these with the common denominator. So multiply -1/3 by 5/5. That's 1 in the form of 5/5. So that we can create a common denominator of 15. Here we've got -5/15 plus -4/15. -5 plus -4 is -9/15, and we do want to reduce this. Numerator and denominator have a common factor of 3. 3 divides into 9 3 times, and 3 divides into 15 5 times. So we divided out that common factor of 3. Final answer, -3/5. Example 2, we're going to find each difference, and if you would like to think of subtraction as adding the opposite, you're welcome to do that. 4 minus 7, you can think of as 4 plus -7, and then we just use the rules for addition. Okay, 7 is a negative term, isn't it? 7 minus 4 is 3, but we give that result the negative symbol, as -7 has a larger absolute value than +4. In Part B, our first term is -9, and our second term is -14. Here we're adding like-signed numbers. 9 and 14 is 23. And then let's give that result the common negative sign. Part C, okay. Here our second term, we want to find the opposite of -11.6. And the opposite of -11.6 is +11.6. Now you may use your basic calculator to add those. If you're doing it by hand, be sure to line your decimals, okay? 7 and 6 is 13. And the result there is 17.3. In example 3, we're going to just pump up the volume here a little bit and use our order of operations. Start in your innermost grouping symbols first. -12 plus 1 is -11. -1 minus 9, you might think -1 plus -9 is -10. Continuing in our grouping symbols. Okay. The opposite of -10 is +10. So this is essentially -11 plus 10, or -1. And -4 plus -1 is -5. Now in Part B, Okay, we've got fractions and decimals, and I'm going to go ahead and convert the fractions to decimals, and we do that by dividing the numerator by the denominator. 3 divided by 2 is 1.5. So negative 1.5 minus 0.75 minus, in second parentheses, we have 0.5 minus 1 divided by 2 is 0.5. So notice in our second parentheses we have 0.5 minus itself, which is just 0. If we subtract 0 from something, we're not changing its value. So our result will come from the first parentheses here. We're combining two negative numbers, so we essentially want to add those together. 1.5 plus 0.75 is 2.25, but notice those are both negative, so let's give it the common negative symbol. Negative 2.25. Next, we will multiply and divide real numbers. So in example 1, let's find each product. 3 times 4 is 12, and there's one negative symbol associated. 9 times 5 is 45 with 2 negative symbols associated with that. And the opposite of negative 45 is positive 45. So you might say, when I multiply differently signed numbers, the result is negative. And when we multiply like signed numbers, the result is positive. That's true. Part C, we're going to multiply 3/7 times negative 1 5/9. Let's convert this mixed number to its improper form by multiplying 9 times 1, 9, plus 5 is 14. This is negative 14/9. Now before multiplying, I'm going to divide out common factors, thereby reducing this before the end. Okay? 3 and 9 have a common factor of 3. 3 divides into itself once and into 9 3 times. 7 and 14 have a common factor of 7. 7 divides into itself once and into 14 2 times. Now multiplying straight across, we have 2/3. That's a negative 2/3, isn't it? Because of the negative symbol. In part D, anything times 0 is 0. That's an easy one. Example 2, find each quotient. Rules are the same here as for multiplying. When we divide differently signed numbers, the result is negative. When we divide like signed numbers, the result is positive. So essentially in part B, we can think of this as 6/5 divided by 1/3, because the answer will be positive. But we don't divide fractions. Instead, we're going to multiply by the reciprocal of the divisor and write this 6/5 times 3/1. Reciprocal of 1/3 is 3, or 3/1. That's an 18/5. And that won't reduce. I'm going to go ahead and leave it in its improper form. Division by 0 is undefined. We just really have no way to deal with that. One way to explain why that is, if I look back at part A, we said 42, I'm just going to think of positive numbers here, okay? 42 divided by 6 is 7, because 6 times 7 is 42. But if we think about division by 0, 42 divided by 0 is what? Okay, is there any number that we can multiply 0 by to obtain 42? No, that doesn't happen, does it? Okay, anytime we multiply 0 by any other non-zero number, or times itself even, we get 0. Okay, so the multiplication doesn't work, therefore the division won't work. Okay. Division by 0 is undefined. Example 3, part A, still using the order of operations here, and we essentially have a couple terms to deal with, don't we? 4 times negative 8 is negative 32. Okay, now these are absolute value bars, and 4 minus 15 is negative 11. The absolute value of negative 11 is positive 11. If we add these differently signed numbers, we subtract them, really, in our heads, right? 32 minus 11 is 21, and we give that the negative symbol because negative 32 carries the weight. It's got a larger absolute value than 11. Part B, we've got our long fraction bar. Let's work in the numerator and denominator separately. Numerator, negative 5 times 2 is negative 10. We can go ahead and do that. We've got a large grouping symbol here, multiplication. 3 times negative 2 is negative 6. In the denominator, we essentially have negative 3 plus 1, and that is negative 2. Back to the numerator, negative 10 plus negative 10, negative 6, and a negative 4 is negative 10. Negative 10 plus itself is negative 20, and negative 20 divided by negative 2 is positive 10. Stay with me. Let's talk about properties of real numbers next. Okay, we've got some properties of real numbers that we get to use within using algebra in expressions and equations. Okay, first we've got the commutative properties of addition and multiplication. We can add or multiply in whatever order and get the same result. The associative properties allow us to add and multiply with different groupings. Okay, A plus B first added to C is the same as A plus B plus C first. Okay, the grouping symbols tell you to do that first. Okay, but the groupings won't change the answer when we're working essentially or specifically with addition or multiplication. The identity properties are important. They don't seem so, but they really are. Any number added to 0 is itself, and any number times 1 is itself, and we get to use those commonly. The inverse properties also are important. Any number plus its opposite is 0 in either order. For example, we would say 2 plus negative 2, its opposite is 0. We've got an inverse property of multiplication. If we multiply a number by its reciprocal, we obtain 1. And there you might think of 2 times 1/2. Its reciprocal is 1. Half of 2 is 1. And then the distributive properties we use to help us simplify expressions and also factor later. A times, in parentheses, B plus C, we get to distribute that letter A and multiply it times both. Okay, and whether your number is at the back or the front, and we can use that property backward as well. For example, let's determine whether each statement below is an example of the commutative, associative, identity, inverse, or distributive property. In part A, we've got 2 times. Notice we've got parentheses around the 5 plus 3. In that second expression, they're gone. So we can see that the distributive property has been used here as the 2 is distributed to each of those terms. So let's write distributive. Distributive property. 4 plus 0 is 4, and this is the identity property. 0 added to any number doesn't change its value. 12 plus 13 is 13 plus 12, and that's the commutative property of addition. Let's write commutative. Part D, this looks like the distributive property again. Compare it to part A, except that it's getting used backward. Okay, here the 3 has been factored out of both of those terms. Okay, so these properties work forward and backward. That's the distributive property again. Now in part E, it looks like we have different groupings or associations. The 3 and 4 are grouped on the left, the 2 and 3 on the right, and this is the associative property of multiplication. Let's write associative for associative property. In part F, we see that we're multiplying reciprocals to obtain 1, and this is an inverse property. (10 plus negative 10 is 0. That's an inverse property as well. That's an inverse property of addition. And what do we have here in part H? We've got different associations again, don't we? That's the associative property of addition. And let's write associative. Boom. Second example, we're going to use the distributive property to rewrite each expression. So in part A, we'll distribute the 8 by multiplying it through the parentheses and write 8 times x minus, now 8 times 6 is 48, so let's go ahead and multiply there. In part B, we're going to distribute negative 5. Negative 5 times 2x is negative 10x. We're multiplying the numbers out front, aren't we? Negative 5 times negative 5y is positive 25y. And negative 5 times 6z is negative 30z. We're multiplying the numbers in front. And those numbers are also called coefficients. And last page here, as we simplify expressions. Remember, expressions contain numbers and variables and math symbols. Okay, it's important to notice those numbers in front as well as what kind of variables we're dealing with. Okay, in example 1, we're going to identify the terms and the numerical coefficient for each term. Now the terms are separated by your plus and minus symbols. So as we think about our terms, 9x is a term, 2xy is a term, negative x squared is a term. We always take the negative or positive symbol with the term, okay? 2/3 y is a term, negative p over 2 is a term, and negative 10 is a term. Okay, so the terms are separated by your plus and minus symbols. Now let's identify the numerical coefficient of each of these terms, and that's just the number part of it. Okay, so in our first term, 9x, the coefficient is 9. The coefficient of 2xy is 2. Careful here, the coefficient of negative x squared is negative 1. The coefficient of 2/3 y is 2/3. Okay, here's another one to be careful with. The coefficient of negative p over 2, okay, the number part is negative 1/2. And that last term is simply a number term or a coefficient unto itself, negative 10. Now, we say that like terms can be combined, and like terms have the same variables raised to the same exponents. For example, in part A, 2m and 3m are like terms. They both have the variable m to the exponent 1, or to the first power. So we can combine them, and what allows us to combine them is actually use of the distributive property backward. Okay, we can pull that m away from our numbers 2 and 3 and add them. As we simplify this expression by combining the like terms, 2m plus 3m is 5m. Part B. Let's use our distributive property. 4 times 6y is 24y, minus 4 times 9, or minus 36, plus 7. Now as we think about our like terms are the number-only terms here. So we write 24y. Now we've got negative 36 plus 7. Those are differently signed, so I want you to think in terms of subtraction. The difference between 36 and 7 is 29, and it's going to be negative because that negative 36 carries the weight in that problem, okay? Lastly, simplifying, we're going to use our distributive property. Negative 4 times 5y is negative 20y. Negative 4 times negative 7 is positive 28. Negative 3 times 2y is negative 6y. Careful. Negative 3 times negative 5 is positive 15. Now combine your like terms. Negative 20y and negative 6y are alike. Combine the coefficients. Negative 20 and a negative 6 combine to negative 26y. 28 and 15 are alike as well. And 28 plus 15, I believe that's 43. Indeed. Now we stop there because these two terms, negative 26y and 43, are not alike. Okay, one has the variable y and the other does not, so stop there. All right. Thank you for hanging with me to the end as we continued there to investigate the real number system.